Hello, physics slackers.
This video on work, energy, and power is brought to you by
water. Without water, we wouldn't be able to do our work, or have energy, or have the power.
Work don't stop. Work don't stop. Work don't stop. Work don't stop.
Okay, let us forget that we are talking about physics for a minute. What is the definition of work in the day-to-day life?
The definition of work is any activity involving mental or physical effort done in order to achieve a purpose.
So that means whenever you are using any kind of mental or physical effort in order to do a particular thing, you are working.
If we were to take an example, we can show how Derrick is studying really hard for Dr. Store's next physics test.
So in this case, Derrick is using some mental activity to achieve a purpose. His purpose is to score well on his exam.
Therefore, we can prove that I'm doing work.
Put in work. Run up on the killer, then I put him in the dirt. Run up in the building, so me gon' squirt that.
Suppose you want to move a book out of your way. You couldn't just do it by simply wishing it would move.
There is only one way to make the book move. This is by making a force act on it.
It doesn't matter what does to push an up on it, as long as it applies enough force to move the book.
Not only do you need a force to do work, but you also need displacement.
Work is done when the force that's applied to an object moves that object. When that object is moved, that's considered displacement, which is defined as the change of position.
Look, I got enemies, got a lot of enemies, got a lot of people trying to drain me of my energy.
Now, have you ever thought about how anyone or anything has the ability to do work?
This is where energy comes into the equation. Energy is the ability to do work.
There are many sources of energy, like the sun, wind, and water, and it can even come from your muscles.
And the most important thing to remember about energy is that it cannot be created nor destroyed.
It can only be stored or transferred.
Did you know that all energy in the world is in two forms? Those two forms are potential energy and kinetic energy.
The difference between these two forms is that potential energy is stored energy in the object,
Whereas kinetic energy is energy of motion or speed.
Now let's switch gears and show you a real physics work example.
Now, there are a couple of different ways Derrick can get up the stairs.
If I was in a hurry, I could run upstairs fast.
However, if Derrick was really tired, since he has been studying for Dr. Store's physics exam,
He could walk up the stairs really slow.
Work hard, play hard, work hard, play hard, work hard, play hard, work hard.
The work generated by Derrick going up the stairs in the y direction really use this equation, which is work equals force times distance. The distance in this case is the height of the staircase, which is 2.3 meters. I got this height from doing a number of steps, which is 11 that Derrick climbed, and one step equaling 8.25 inches or 20.95 centimeters. I did multiply 20.95 by 11, and then I converted that answer to meters, which is 2.3 meters. And then for Derrick's mass, it's 68 kilograms, and for acceleration due to gravity is 9.8 meters per second squared. We plug all of this into our force of weight, which is F in this case. We can do 68 kilograms, which is mass, times 9.8 meters per second squared, which is the acceleration due to gravity. If we do this, then we get 666.4 newtons, which is Derrick's force of weight in the y direction. For work, we do the force of weight, which we got up here, times the height in the y direction, which is 2.3 meters. So 666.4 newtons times 2.3 meters gives you 1,532.7 joules, which is Derrick's work done in the y direction going up the stairs.
Now, if we were to calculate the power generated by Derrick to go up the stairs, we would use this equation, which is mass times acceleration due to gravity times height over the changing time. Now here we're calculating the power generated for him to run up the stairs, which is 68 kilograms, which is his mass. Acceleration due to gravity is 9.8 meters per second squared, times the height of the staircase, which is 2.3 meters over 3 seconds, which gives us 510.9 watts. Now here we're calculating his power to go up the stairs by walking. Again, we have 68 kilograms as his mass, 9.8 meters per second as his acceleration due to gravity, times the height of the staircase, which is 2.3 meters over 7 seconds, which will give us 218.9 watts.
And that's all, folks.
This video on work energy power.
Oh, we all saying it together?
That's what I thought.
Now, sorry. Let's switch gears and show you a real physics work example.
Suppose you want to move a book out of your way. You can do it by...
To calculate the power used. Ooh.
9.8. Since the force of weight is the distance in the y direction. In this case, you would get 15,032.